Hello, Dr. Kane and Jill. I'd like to give you a little update, a visual update this time, as the software from the software front. And just a few minutes, I'm going to go through the basic workflow, which includes loading the CT scan, just like you guys normally do in the clinic. And the next thing is extracting the bones of interest, so L4, L5, and then applying the tool that I've created to actuate those bones relative to one another. And then at the very end, I will describe sort of the future direction of where I think it's going, and then open the floor to you guys via email. So I'm just going to get started here. Open Slicer. Again, Slicer is that 3D medical imaging software, which is open source, and it allows for me to program in it and have access to all of these features programmatically, which is very nice. So I'm going to start by loading some DICOM data. So I'll take KC's data. I'm just going to load up real fast. You see it in the viewer. I'm going to describe the volume here in the three-dimensional plane here, and then select a nice viewing setting. Just recenter it here, and you can see the lumbar spine here pretty clearly. However, now extracting, say, L4 and L5 here is another story. It's not exactly trivial, and so much of the bone segmentation that is done is manual, and for the sake of this tutorial, I have manually extracted L4 and L5, and I'm not going to show it here. I'm just going to load it in. And just give me a second. Just pull up the two files. And there you go. It should be loaded in. They should come here. L4, L5. It's the gray. Looks good. Alright. Now I'm just going to, the volume's not needed. And now I'm going to just change the properties real quickly, and makes it a little easier for you guys to see. So that's L4 and L5. Okay, and now what I'm going to do is show you my tool. I created this Orthopedic toolbox. It's a module here that has two features at the moment. One is not currently being utilized, but I intend to use the spine segmentation tool. This is the tool that the fellow from Google, who currently works at Google, developed several years ago, and he's offered to let us use it, and at the moment he is toying around with the CT I sent him. So I have not heard back from him yet. I didn't hear from him this week. And the second one is what we have talked about from the start. It's this range of motion tool. And it's fairly simple, I hope. And you know, you load two bones. You load your L4 and L5. And then just look at them again. And then it's really basic. I, the user, I want to add a line of rotation to rotate L4 about L5. Pretty simple. Slicer has a built-in feature, ruler, and I'm just going to draw it. And now I need to just orient the ruler to make it kind of look like where these bones, I know, rotate about one another. It's mid-joint space, roughly speaking. It doesn't have to be perfect for this one. It looks pretty good. So let's interior view. Just give you a nice view. All right. So we select those the line, the axis of transformation, and we're going to fix L5. So fix L5, and then I need to then choose the two models that I want to, that serve as the holders, if you will, for the transformed bones. And so you can save it afterwards. And so now let's just assume I want to rotate 10 degrees in extension there, and you see this gray is what 10 degrees in extension is from relative to what it used to be, this opaque color, opaque surface, if you will. And it's pretty basic. You just toy with it, move it around, and it does what you're expecting it to do. So that's essentially it at the moment. As you can see, the next steps are to integrate the implant into the joints, or into the disc space, and also integrate asking the question whether or not a collision has happened between the two vertebrae, like in this facet joint here, for example. Currently, the user interface does not show the intersection, but in the back in the code where it's running, it does compute the volume of intersection that happens between the two bones. So there is, from the mathematical standpoint, this is happening in real time. It's just a matter of me connecting it. So that's the next logical place to go. And like I said before, you have implants, and this is definitely going to change. I'm not exactly sure how yet, but that's something for this week to do. And, going forward, the last step really of the process is to define, iterate along some plane in this, some range of angles, and then ask the question of whether there's an intersection or not, thus producing the range of motion in the flexion extension plane. So I will leave it there. If you have any questions, feel free to email, call me, whatever's comfortable for you guys. So thank you. Take care.